Hello everyone, you are welcome to today's class. In today's lesson, we are going to learn about the measurement of resistance with special focus on one important method called the substitution method. By the end of the lesson, you will understand the principle, the apparatus, the procedure, and the precautions involved. So let's begin. There are several methods used to determine the resistance of a resistor. However, in all experiments involving the measurement of resistance, one very important rule must be followed. Only small current should be allowed to pass through the resistor and measuring instrument. If large current flows, the resistor can heat up, its resistance may change, or the measuring instrument may get damaged. Some common methods of measuring resistance include the substitution method, the ammeter-voltmeter method, also known as Ohm's law method, the potentiometer method, the Wheatstone bridge, and the meter bridge. In this lesson, our focus is on the substitution method. Principle of the substitution method. The substitution method is used to determine an unknown resistance, usually represented as Rx. If an unknown resistance is replaced with a known adjustable resistance and both produce the same current in the circuit, then their resistances are equal. That is the basic principle behind the substitution method. Now let's look at the materials needed for this experiment. We need a battery, a key or switch, a rheostat, which is a variable resistor, an ammeter or galvanometer, a resistance box, the unknown resistance, and connecting wires. In the circuit arrangement, a resistor is connected across the ammeter to protect it from excessive current. Here, the rheostat serves as a shunt. The ammeter is connected in series with the battery. The unknown resistance Rx, and the key. We now have the complete circuit arrangement. First, close the key and slowly adjust the rheostat until the ammeter reading shows a suitable deflection, preferably close to full-scale deflection. Take note of this deflection carefully. Here, our ammeter reading is 0.4 ampere. Next, open the key and remove the unknown resistor from the circuit. Then replace it with a resistance box, making sure that no other part of the circuit is changed and rheostat setting remains the same. After that, remove plugs from the resistance box gradually until the ammeter shows exactly the same deflection as before, 0.4 ampere. Once the same deflection is obtained, note the value of the resistance on the resistance box. Here we have removed plugs of 1 ohm, 2 ohm, and another 2 ohm on the resistance box. The value of the unknown resistance is equal to the value of the resistance box, which means the value of the unknown resistance is 5 ohm. It's important you understand how a resistance box works. A resistance box allows us to obtain different known values of resistance by removing plugs. This makes it very useful in resistance measurement experiments like the substitution method. You can click on the link in the description to watch a short video that clearly explains how a resistance box works. Before we end, let's note some important precautions. Ensure that only small current flows through the circuit. Do not change the rheostat setting during substitution. And make sure all connections are tight and clean. And that brings us to the end of today's lesson on the measurement of resistance using the substitution method. If you found this explanation helpful, like, share it with your classmates, and subscribe for more physics lessons. See you in the next class. Happy learning.